Hello, welcome again. We are solving some questions of production engineering. The topic is metrology. Question number 14 is what are the upper and lower limits of shaft represented by 60F8? Use following data. Diameter 60 lies in the diameter step of 50 to 80 mm. The fundamental tolerance unit I in micrometer is 0.45 d raised per 1 by 3 plus 0.001 d, where d is representative size in mm. Tolerance units for IT8 is 25i. Fundamental deviation for F shaft is point minus 5.5 d raised per 0.41 micrometer. Options A for upper and lower limits of the shaft is lower limit. Option A, lower limit 59.924 mm, upper limit 59.970 mm. Option B, lower limit 59.94 mm, upper limit 60.000 mm. Option C, lower limit 59.97 mm and upper limit 60.1016 mm. Option D, lower limit 60.000 mm and upper limit 60.046 mm. So here, as it is given that the diameter 60 lies in between the steps of 50 to 80, so we will not use that 60 for calculation of fundamental deviation and tolerance. We will find out diameter that will be used in fundamental tolerance unit and in fundamental deviation and in tolerance value. So that diameter will be 50 root 50 into 80. Okay, so that is 63.245 mm. Now to calculate the tolerance unit and tolerance value and fundamental deviation, will use that D. So now the formula for I is given as this. Okay, so now if we put the value of D in this, will get I, and I will be in micrometer because it is given that is in micrometer. Okay, and it would come out as 1.8532 micrometer, and fundamental deviation is given as minus 5.5 d raised power 0.41. This is also in micrometer, but d is in mm. So it will be 30.11 micrometer or minus 0.03011 mm. So fundamental deviation will be. Now it is now given that tolerance value for IT8, because this is 60 F8, so it is will use IT8, so that is 25i. I we have calculated from this. So tolerance value will be your 25i, or it will be or 46.33 micrometer or 0.046 mm. So suppose now we have tolerance value and we have fundamental deviation, and we have basic size as 60. Okay, so now we calculate upper limit and lower limit. So this is the basic size of the shaft. Okay, so first of all, fundamental deviation from the basic size is given. So this is your half of the fundamental deviation, and half is on this side and half on this side. This is also the basic size of the shaft, because this is your shaft. Okay, and this basic size, and Fm by 2, fundamental deviation by 2, and or fundamental deviation is given to calculate upper limit of the shaft. Okay, so that is the upper limit of the shaft. Okay, so the upper limit is basic size minus fundamental deviation, so 60 minus 0.0115. So as fundamental deviation is minus 0.033 3011 mm. Okay, so we'll subtract this. Okay, so that will be 59.970 mm. Okay, and now to calculate the lower limit, we'll subtract tolerance value from the upper limit. So upper limit minus lower limit, that is 59.924 mm. So that will be your lower limit, and it will be 59.924 mm. So answer is option is. Okay. Lower limit 59.924 mm and upper limit 59.9 mm. As fundamental deviation is in minus, so the size of the shaft will be less than 60, or we can say the upper limit of the shaft will be less than 60, and lower limit will be further lesser. So here options are here more than 60 option is given for the upper limit, so that is wrong. So the answer is option A.